In preparation for the for the final exam, when you're working on a second part of your review problems from Pink Sheets review package, I'll try to give you some hints that you may use when solving some of the problems in here. So first we're going to start with very basic formula that we're going to be using throughout this course. And I have a couple steps flowchart. And in this flowchart, we see that first of all, we're going to ask ourselves a question whether the integrand that we have is of a simple power. If that's the case, then we're going to be using just straightforward formula, general power formula, and that's integral u to the n du is equal to u to the power of n plus 1. We're increasing power by 1, dividing by the new exponent, and then plus constant of integration. Remember that n cannot be equal minus 1 because that would be division by 0. So some example of this first step, we may have a situation that we may do just a minor rewriting. Like example A, we just have to rewrite the integrand, this expression in here, using fractional exponents. So the first one, we don't have to do anything. It's x to the power of 1/2. Second one, we're introducing negative exponent. So that's x to the negative 2. And the last term is just pi. And at this stage, we can just go ahead and integrate, and that will give us x to the power 1/2 plus 1 is 3/2 divided by 3/2 plus minus 2 plus 1 is x to the power of minus 1 divided by minus 1, and plus pi dx is pi x, and then plus c. So that's a straightforward. Same thing with example B. We don't have to do anything. We just apply directly this formula in here, and we're integrating because u is function of x, and everything is already in correct order because we have exponents. Everything is integratable easily. In example C, we see in here that we are not in the form that we can integrate. So the very first thing we basically see if there is anything that we can do with this integrand in here. And we examine the radicand, and we see in here that that's nothing different than integral of square root, but inside of the square root we have x plus 2 square dx. And then we can simplify that. That's nothing different than x plus 2 square, and square root is to the power of 1/2 dx. Then we simplify that, and that becomes integral of x plus 2 dx. And now again we can go and apply this formula in here. And now we go to the second step in the chart in here, and we're basically saying that the integrand is not in a simple form, but we're looking and asking ourselves a question: is there a function differential relationship? So in other words, we're asking, is there any way that we can use u substitution so we can rewrite this integral into this format in here? So in this case, example A, we're asking ourselves, what would happen if we let u equal 2x plus 4? So if I let u equal 2x plus 4, I'll have an integral u to the power of 7 dx. But now, what is my du? Differential of u is going to be equal to derivative of 2x is 2, so differential is 2 dx. Derivative of 4 is 0. I have only one dx, so I divide both sides by 2. And then I can go in here and say that this is the same thing as u to the 7th times dx. Dx is equal to du over 2. And I can go and integrate now. Now let's go to example B. In example B, we're looking again. So definitely we cannot integrate using the formula directly. It's not a power, so we're looking for u substitution. So if we say let u equal to, if we let u equal x plus 1, we'll see that that doesn't help. But we have a square root of x squared plus 2x plus 6. And we see that if we let u equal the radicand, then square root of x squared plus 2x plus 6 can be rewritten as let u equal x squared plus 2x and then plus 6. So differential of u is going to be equal to 2x plus 2 and then dx. This is the same thing if we factor out 2. So we'll have a x plus 1 dx. And you see that we have in the numerator, we'll have a x plus 1 dx. So we just need to solve for this. So we divide both sides by 2. And then we can go and rewrite this integral. So integral becomes x plus 1 dx is du over 2 divided by square root, and this is u. So that's the same thing as 1/2 integral du over square root of u is the same thing as u to the power of 1/2. If we introduce negative exponents, so now we have 1/2 integral u to the power of minus 1/2 and then du. And we can integrate that. So this is the idea that we're going to, throughout those review problems, we're going to be looking for one of those three cases. Case 1, we're basically looking, do we have a straightforward, a simple power that we can just go and apply directly this power formula? If not, then we're saying, do we have to rewrite using fractional exponents or negative exponents to get to this form so we can apply it? If that doesn't work, then we're looking for a u substitution, and that's the case in here. Also, you may have to go and do some other algebra. So like in this case in here, u substitution would not work. Direct integration does not work. So we're basically looking for some algebra solution. And in this case, we found a perfect square in the radicand. So we're going to start doing that throughout the review problems. And most of the time, I'm not going to be finishing. I will just get to this formula so you can go and finish yourself. Okay, so this is the first case. We're obviously seeing that this is nothing different than direct integration. So I'll have an integral of 4x cubed, so that's 4x to the 4th over 4 and minus over 4 and minus x to the power 1 plus 1, which is 2 divided by 2 plus c, and then simplify this and you have your answer in here. Okay, let's go to a second problem. So this one is identical again. We have the same thing as before, direct integration, so it will be 5x plus 3x cubed over 3, so we don't have to do this one. Okay, in example 3, we just have to multiply through, so that would be the integral of 2x minus 2 x to the power of 3 halves dx, and now we can integrate, and that gives us 2x to the power of 2 divided by 2 minus 2x to the power of 3 halves plus 1 is 5 halves divided by 5 halves, and then plus c. This one can be simplified, so that's 1, 1. So this is equal to, this is minus, by the way, so this is going to be equal to x squared, and then minus 4 over 5, after simplification, x to the power of 5 halves, plus c. Similar situation with this one, we have to now multiply through, so integral of x times, integrand x times x is x squared, x times minus 3 is minus 3x to the power of 5 dx, and now we have exactly the same as before, so it's going to be x cubed over 3 minus 3x to the fifth, so it would be x to the sixth divided by 6, and then plus c, simplify, and we have our answer. Now we have a definite integral, so situation is similar as with indefinite integral. We have, first we're going to use fractional exponents, so it will be x to the plus 1 over x squared is x to the negative 2 dx. Then we integrate that and evaluate, so x to the power of 2 divided by 2 plus x minus 2 plus 1 divided by minus 2 plus 1, and then limits of integration from 1 to 2, and that gives us equal to x squared over 2, and then plus x to the negative 1 over negative 1. So that is equal to, put two sets of brackets and substitute first the upper limit, so from 1 to 2. So plug in 2, 2 squared divided by 2, plus x 2 to the power of minus 1 divided by minus 1, and then 1 to the power of 2 divided by 2, plus 1 to the power of minus 1 divided by minus 1. And at this stage, you can use your calculator to evaluate. So that's going to be integral, and you put your limits. Lower limit is 1, upper limit is 2, and you put your function x plus 1 over x squared, and just press equal and copy that answer right in here, and you are free. Second question, one step in between, you have to multiply first. So you're going to have a from 0 to 2, x times 4 is 4x minus x squared dx. Now you can integrate. So this is going to be 4 times x to the power of 2 divided by 2 minus x to the power of 3 divided by 3, limits from 0 to 2, and do exactly the same as in before. Number 8, very similar, multiply first, so integral from 0 to 1, x times x, x to the fourth, plus x dx. Now integrate and evaluate. X 4 plus 1 is 5 divided by 5, plus x squared divided by 2, limits from 0 to 1, equal to, and 1 to the 5th power divided by 5 plus 1 squared divided by 2, 0 to the 5th power divided by 5 plus 0 squared divided by 2, so that's the whole thing is 0, and this is equal to 1/5 plus 1/2, which is equal to 10 divided by 5, 2, plus 10 divided by 5 is by 2 is 5, so it's 7/10. Oh, you can use your calculator. Now the next one, very similar. We have to again rewrite first. So this is 3 plus 2x to the negative 3 dx. And this is indefinite integral, so just a question of integrating. 3 dx is 3x plus 2x minus 3 plus 1 divided by minus 3 plus 1, and then plus c, and that is equal to 3x plus x to the power of minus 2 divided by minus 2 plus c, and so 2 and minus 2 cancels, so that gives you 3x minus 1 over x squared plus c. Number 11, it's definite integral, and again we're looking here and we definitely cannot use our formula u to the n du is equal u to the power of n plus 1 divided by n plus 1 plus c, and not equal minus 1. So the next thing, before we go to substitution, we want to see if there's anything that we can do as far as algebra goes, and we examine the radicand, and we see that this is nothing different than x plus 3 squared, and that is equal to x squared plus 6x plus 9. You can use your calculator to find the roots by set x squared plus 6x plus 9 and use your calculator quadratic formula and find the roots. So you're going to have a option 6, 2, and then you have 1, 6, and 9. And you're going to get the roots of double root 3. So now this becomes integral dx from minus 2 to 5 cube root, and this is x plus 3 square cube root, which is the same thing as integral from minus 2 to 5 and x plus 3 to the power of negative 2 over 3 dx. Now let u equal x plus 3, so du is going to be equal to dx, so that becomes indefinite integral of u to the power of minus 2/3 du, and that is equal to u to the power of minus 2/3 plus 1 divided by minus 2/3 plus 1, and then plus c, substitute back. Minus 2/3 plus 1 is u to the power 1/3, but u to the power of 1/3 divided by 1 times 3 plus c, and then plus plug in back u is equal to x plus 3, so that is equal to 3 times x plus 3 and limits from minus 2 to 5, and that is equal to 2 brackets. Put upper limit first, so I have 3 times 5 plus 3, and this is to the power of 1/3, right? 5 plus 3 to the power of 1/3, and minus 3 times minus 2 plus 3 to the power of 1/3, and evaluate that. The next one, the very first thing we have to do is multiply through, so you have a x times integral of 1 minus x squared dx, and plus x times 1 is just x dx, and limits from 0.35 to 0.85, 0.35 to 0.85, and that is equal to, the first one we have to let u equal to 1 minus x squared. Let u equal 1 minus x squared, and then du is going to be equal to minus 2x dx, and that's the reason we're letting u equal to, because 1 minus x squared, because differential of that is present in here, x dx. So we need only x dx, so we're dividing both sides by minus 2. So minus 2 and minus 2 cancels, and that becomes, so is equal to indefinite integral, because we're changing the variable. And so x dx is square root of u, and x dx is equal to minus du over 2. And the second integral we integrating right away, so it's x squared over 2, limits 0.35, 0.85. And now we can finish off with the first one. So this is nothing different than minus 1/2 integral u to the 1/2 du, plus this one is nothing different than 0.85 squared divided by 2 minus 0.35 squared divided by 2, and the first part, it's minus 1/2 u to the power of 3/2 divided by 3/2 times 2/3, and then plus whatever we get from here, and then evaluate again for u. You're going to substitute 1 minus x squared, so this is going to be equal to 2 and 2 cancel, so it's minus u is 1 minus x squared, the power of 3/2 divided by 3, and limits from 0.35 to 0.85, plus whatever we get from here, and that will be all. Number 14, we definitely don't see integral of the form u to the n du, so we're basically looking for not much algebra we can do in here, so the only hope for us is letting u equal something, and then we're recognizing that we have 1 over x squared dx present, so if we let this equal u, because derivative, if u is equal to 1 plus 1 over x, which is the same thing as 1 plus x to the negative 1, then differential is going to be equal to minus 1 over x squared, right, dx, because this is nothing different than minus 1 times x to the negative 2. So now I have a 1 over x squared dx, so if we multiply both sides by minus 1, I have a minus du is equal to 1 over x squared dx. So now this becomes integral 1 over x squared x dx is minus du, and this one is square root of u times minus du, because this is minus du in here, and this is your u. And that gives you integral minus u to the 1/2 du, which is equal to minus u to the power of 1/2 plus 1 is 3/2 divided by 3/2 multiplied by 2/3, and then plus c, which is equal to minus 2 over 3. U was equal to 1 plus 1 over x, 1 plus 1 over x to the power of 3/2, and then plus c. In number 15, we see the only hope for us would be let u equal whatever we have in parentheses in here. So if I let u equal 7 minus 2x, so if I say let u equals 7 minus 2x, then differential of u is going to be equal to minus 2 dx, and in this case dx by itself is going to be equal to minus divided by minus 2, so this cancels. So now I have 3 I can take out sides, and then I have an integral 7 minus 2x, that's u to the power of 3/4, and dx is equal to du over minus 2, which is the same thing as minus 3/2, and then u to the power of 3/4 plus 1 divided by 3/4 plus 1, and then plus c, which is equal to minus 3/2, and then this u is going to be 7/4, but u is equal to 7 minus 2x to the power of 7/4 and divided by 7 and times 4. So 4 and 4 cancels, 1, 1, plus c, so that is equal to this is 3/2 in here, so this is not, this is half, so this is 2, so it's going to be a minus 6 over 7, 7 minus 2x to the power of 7/4, and then plus c. So this one again, the only hope we have, very similar problem to the previous ones. Let u equal to 3x plus 1. So then differential of u is going to be equal to 3 dx. We have only 1 dx, so we divide both sides by 3. Cancel, so this is equal to integral 3x plus 1 is equal to u to the power of 1/3 dx is equal to u over 3, and that gives you 1/3 integral u to the power of 1/3 du, and now we can apply our formula. Integral u to the n du is equal to u to the n plus 1 divided by n plus 1 plus c. Number 18, definite integral. So again, the only hope we have, let u equal to 3x minus 2. So differential of u is going to be equal to 3 dx. So this is equal to, divide both sides by 3. So this is 2 we can take outside. Dx is equal to du over 3. And in the denominator we have 3x minus 2, which is u to the power of 3/4, which is the same thing as 2/3 integral u to the negative 3/4 du. And again, we can integrate now. We have indefinite integral, and if we see in here that we have 1 minus 5x to the 4th, if we take derivative of this, we'll have a minus 20x cubed, and we have here x cubed. So that would be good substitute just inside of parentheses as u. So if we let u equal 1 minus 5x to the 4th power, then differential of u is going to be equal to minus 20x cubed dx. Divide both sides by minus 20. So this cancels. So now this big trick we can take outside. And now I have a x cubed dx, which is equal to du over minus 20. Du over minus 20. And then I have a 1 minus 5x to the 4th, which is u to the power of 1/3. If I simplify this, minus 3/20 integral u to the power of 1/3 du. And we know how to integrate this. So this is going to be minus 3/20 u to the power of 1/3 plus 1 is 4/3 divided by 4/3, so multiplied by 3/4, and then plus c. And you can finish that. Okay, in this case, again, we're looking for derivative of the radicand. If we let this equal u, derivative of 6 is 0, derivative of 9x is 9, derivative of minus x cubed is x squared, so we are on the right track. So I say let u equal to minus x cubed plus 9x and then plus 6. So differential of u is going to be equal to minus 3x squared and plus 9 dx. If we factor out minus 3, so du is going to be equal to, factor out minus 3, so I'm left with x squared and minus 3 dx. We have in here x squared minus 3 dx, so we divide both sides by minus 3. So minus 3 is 1, 1. So this becomes integral x squared minus 3 dx is du over minus 3 divided by square root of u, which is the same thing. Minus 1/3 we can take outside, and now we have an integral. Square root of u want to put into numerator, so it becomes u to the negative 1/2 du. And we know how to integrate that. So this is going to be equal to minus 1/3 u to the power of minus 1/2 plus 1 is to the power of 1/2 divided by 1/2 and then plus c, which is equal to minus 2/3. U was equal to minus x cubed plus 9x plus 6 to the power of 1/2 and then plus c. Here we've got definite integral, and again we see that inside of the second parenthesis we got x squared plus 3x. Derivative of x squared is 2x, derivative of 3x cubed is 9x. So if we multiply by 2, we're going to get the same differential in here. So if we let u equal to x squared plus 3x cubed, then du dx is equal to 2x plus 9x squared. X squared. We need 4x, right? First of all, multiply both sides by dx to get differential. So du is equal to 2x plus 9x squared dx. If we multiply both sides by 2, we have a 2 du is going to be equal to 4x plus 18x squared dx. So now this expression here is equal to du. And this is equal to u to the power of 2. So now I'm going to have an integral of 2 du times u to the power of 2, which is equal to, so it's an indefinite integral, because we changed the integrals, variables. So now I'm going to have an integral of 2u squared du, which is equal to 2u cubed over 3 plus c. Substituting back original variable, u was equal x squared plus 3x cubed to the power of 3, and limits from 0 to 2, and then we're going to have a 2/3, and then 2 sets of brackets. Upper limit first, so it'll be 2 squared plus 3 times 2 cubed. Oh no, this is actually 2 cubed, right? 2 squared plus 3 cubed, and then everything is cubed. And then second one is 0 squared plus 3 times 0 cubed, that's 0. So this gives us 2/3 bracket 2, 4 plus 2 times 2 is 4, 8 plus 24, and everything to the power of 3. And you can use your calculator to verify this answer. So 28 cubed times 2 divided by 3, it's supposed to be equal to 43,904 divided by 3. You can use your calculator, put answer from 0 to 2, and put your function 4x plus 18 x squared plus 3x cubed square dx, and then press sign equal. So that's from calculator.